Yes. Hello everybody, good evening. Welcome to BYJU'S 9 and 10 and I am Trupti, your chemistry teacher, and today we will be talking about states of matter. Yes. Okay, let me see how many of you are there here right now. Yeah. We have... Okay. Hello, hi Fiza, hi Ankit, hi Muskan. Manya Kriti ma'am is on leave, long leave. So currently I am taking 9th and 10th chemistry for you guys, right? Kriti ma'am doesn't want you guys, your studies to be affected, right? That's why I am here. Yes, hi, hi, hi. So many people saying hi. ये ऐसे भाग रहा है. I can't read the name. Usha, hi. Dance Fit, hi. I can't read anybody's name right now. Okay, how are you all? How are you all? Okay, last video देखा आपने? Yes. Matter in our surroundings का introduction वाला देखा सभी ने? Yes. Yes. I am good. I'm good. Yes. Okay. So, yes. अरे नहीं देखा तो जाओ यार देखो. I'm good. Hi, I'm good, Fiza. Yes. Hello. Okay. Let's get back to the business. Okay. So, अगर last video किसी ने नहीं देखा है, तो in that video we discussed about what is matter. What is matter? Matter is something that has mass, occupies space, and is perceived by our senses, right? And also, we discussed about composition of matter. What is matter made up of? They are made up of tiny particles, chotto, right? Okay, after that we also discussed about the characteristics of particles of matter. That is, they have interparticle spaces, they are in continuous motion, they are never on rest, okay? And also, they have force of attraction between two particles. There is a force of attraction between particles. So, these are the characteristics that we discussed in our last class. Yes. Okay, Shan, 8th class chemistry start तो हो रहा है. Okay, we will soon be taking 8th class sessions also. ठीक है? Yes. Okay, so this was discussed in our previous class. Okay, so let's start today's class, and there is a small activity that we'll do. It's activity time. Yes. Okay, are you ready for the activity? I want you guys to be ready. There's a very simple and quick activity that we are going to do. Yes? Okay. Okay, are you ready? Okay. So, I have few things over here. The shadow of those things, not things exactly. So, I have few shadows and you have to identify them. Identify these three substances. Very easy, very easy, right? So, what is this? This is bag. And what is this? Guitar. And this is key. How did you know that this is a bag, this is a guitar, and that's a key? How did you know? It's because of the shape, right? It's because of the shape. Bag is bag in that shape. Like, you know it is bag. You identify the shape of that bag, right? Guitar को देख के, मतलब you don't even have to see. You know the shape of the guitar and you know the shape of keys. What do you mean? What can you conclude by this? They have a definite shape, right? So these things, there are certain things, they have certain definite shape. So let me take one more thing that has a definite shape. Say, for example, let me take a rock. I'll take a rock and I'll try to, I'll apply some force and I'll try to change the shape. Okay, I have a duster here, okay? I'll just try to change the shape. It is not happening. Yeah, see? I can't. It's resisting that force that is, I'm forcing it to change the shape. It is resisting, right? So this particular characteristic is what you call rigidity. So it resists the shape and volume. Okay, so this rigidity, or the resistance, see, if you look at the particles of that substance, those particles are like very tightly packed. They don't even have spaces. If you can see, like they have very, very, very less space between them. So this particular concept, these particles don't have space because the force of attraction is really high. The force of attraction between the particles is very high, so that they are tightly, very tightly packed. And this leads to the rigidness or the rigidity, what you call that, the characteristic or the resistance to change of shape is called rigidity. It's because of the very less the space present in between the particles, and also the high force of attraction between the particles. Got it? And these substances, which are very rigid and they have definite shape and they have definite volume, are something that we call solids. Yes, they are called solids. So what are the characteristics of solids? Okay, so they have definite shape that we already discussed, and also they have definite volume, and they are rigid. And do you think I can compress this? Let me try compressing. Can I? Can I compress? No, they are not compressible, they are incompressible, and the particle space, the space between the particles are very, very less, and they are negligible. So that is the reason they use negligible in interparticle space. Also, the force of attraction between the particles are high. It's very, very high. Cool. Are we clear? So these are the characteristics of solid. Yes. Yeah, you're right, Dansvit. It's actually, depends on how strong, or the force, the external force, how strong it is, right? And it is not easily, breakable, or they are not easily compressible, or solids are not compressible at all, okay? But they are not, the rigidity actually is very strong. Yes, solids have definite shape, definite volume, and they are very rigid and incompressible. Cool? Yes. Now, I can see some of you are asking some of the things that I'll be addressing right away. Okay. So, think of rubber band. You have rubber band. Try stretching it. First, tell me, is it a solid? Rubber band, is it a solid? It is, right? It is a solid. But when you stretch it, it changes shape, right? So there are, some exceptions. This changes, particularly in this case, rubber bands, they change shape under force. But again, when you release it, it regains its original shape, whatever it is there, right? Yes. And also, look at sugar. If I have a bowl of sugar and I just transfer that bowl of sugar to say into a glass, it takes the shape of that glass. Do you think sugar is solid? think about the sugar, one individual sugar crystal, right? They are powder, right? So think of individual crystal. Do you think the shape will change easily? Like when I put it in another jar, will the shape of that crystal changes? The sugar crystal will change? No, right? That is the exception here. So it takes the shape of the container, but if you look at the crystal, it won't change. The shape won't change. Now coming to the most asked question, sponge. Why do you think we can squeeze or compress sponge? Why do you think we can compress sponge? See, we can compress sponge until there are air, like still air left in the sponge. So what is sponge? Sponge is like, it has pores and it has, air inside. And when you squeeze it, the air comes out. But after squeezing and you reach the only pure sponge material which is there, it is not compressible. It is not compressible when you reach a pure sponge material. Yes? Even dough is the same, Smriti. So you can try compressing, right? Dough is semi-solid. All these things, dough is actually not completely solid. Okay? Yes. Okay, so this is about solids. Now tell me, is it only solid which is the state of matter that you can see around you? Yes? Ice is solid when it is frozen, right? It is solid. Ice is solid. Ice cream is not solid. You have studied about ice cream and colloids and all in your previous class. Try to remember, it's not solid. Yes. Okay, it's so long, I can't read. Wait. Considering that solids have fixed shape, volume, we do reconcile this with phenomena like where solids expand when heated. Yes, that is because the energy between the particle increases when heated, right? So that is how they expand. But the expansion is also, it's not like if I have this size, it becomes this size, right? It's like slight change of the size, right? So exactly, it's the thermal expansion. You have to provide some energy, some force to change the shape or the size of the solids. Got it? Yes. Jelly and all are not solid. They belong to a category called colloids, right? You have studied about this in your previous grade. Yes. Okay. Jelly, slime and everything, these things, I told you, you guys have already studied in your 9th grade under colloids and other things. Is matter around us, the pure chapter. Yes. Yes. Okay. Cool. Let's move further. Okay. Tell me, is the solid only one state of matter that you can see around you? Let's explore the other states of matter then. Yes. Yes, ice cream is a type of colloid. Please check it in your textbook, or you can check it in the videos in our channel, which has done by Kriti ma'am. Yes. Okay. So, let's go to the next state of matter, which is liquid. Okay. So, now I have a glass of water here. Okay, I have a glass of water and I'll just transfer the same water. So look at the shape of this first. Okay, so this has a glass shape. So liquid, the water has taken the shape of the glass. Cool? Yes. Now I'll transfer this water to a bottle. What will be the shape of the water now? Yes, it will take the shape of bottle, right? Okay, now think I spilled it over. I'll just spill the water on the table. And the water, does it have a definite shape? No, there's no definite shape for liquid, right? So, there's no definite shape. Cool. Now think I have 1 liter of water in a glass, in a big glass, okay? This big glass, I have 1 liter of water. And I'll transfer exactly 1 liter of water to another, maybe a jar, a jug, okay? I'll transfer it to a jug. Now, how much water is there in jug? It's 1 liter, right? Did the volume change when I transferred it to another container? No. So it has definite volume. So the volume doesn't change, right? Okay, fine. So for the next characteristic, I have a syringe here. Let me take some water. Okay, I have some water. Let me take some water. Yes. Okay, so there's some gas in this. Let me remove that. Okay. So, I have water. Shall I take more? Let me take some more water. Okay. So, I have a syringe full of water. Okay. Can you see? Yes. Now, let me close the tip of this and I'll try to squeeze it. I'll just compress it. Do you think it is happening? It's not happening, right? It's not. So you cannot compress a liquid. Okay. So that means liquid is not compressible. It's incompressible. So let me put this water back into this jar, right? Okay. So these are the few characteristics of water or liquid in general. Okay. Okay. Now if you think of water, just close your eyes. I'll say water. What comes into your mind? You can see water on a beach, on in a river, and you see water flowing, right? Think of the water which is flowing. Water can flow. It's very simple. Very, very simple. Water can flow. Okay, open your eyes. Okay. Okay. So water can flow. What is this flowing ability called? What is this like flowing ability called? Fluidity. So ability of a substance to flow is called fluidity. Yes. Okay, so these are few characteristics of liquids. Water means liquids, right? So there's one more example of liquid. Give me some more examples of liquids other than water and milk. Yes. Some other example. Yes. Juice. Yes. Yes, very good, Fiza. Yes. Yes, lemonade, juice, everything comes from same, no? Yeah, petrol. Yeah. So we have few other examples as well. So let us look at the characteristics. So it doesn't have definite shape, but it has definite volume and it is not compressible and they have fluidity. That means they can easily flow. They can flow easily. Yes, it depends on the viscosity of the liquid, the fast and slow fluidity, the fluidity and all those things. तो सौरभ सर को पूछना छोड़ना मत कि ये फ्लूइडिटी का सही से बताओ, ठीक है? नेक्स्ट टाइम व्हेन यू सी सौरभ सर ये क्वेश्चन पूछना कि why do some liquids flow slowly, some flows very very quick, चला जाता है, right? Yes. Okay, so they have larger interparticle spaces when you compare it to salt. It's not like हाँ पूरा ऐसे, like there are a lot of spaces there. No, when you compare it to solid, the interparticle space, the space between the particles, is a little more than that of solids, and they have weaker force of attraction between the particles when you compare it to solid again. Yes. Okay. Right? Okay. Now let's come to the last state of matter, that is gas, gaseous state, right? Yes. Now think, observe. There are particles. This is the part, these are all the particles of air, right? Yes. These are the small particles, and look at the difference between the space between the particles. How is it? Like very tightly packed? No, they are not tightly packed. The space is very, large, very large interparticle spaces. And the force of attraction, now you tell me, what is the force of attraction? It will be like very, less, or it's like very strong force. It's very less. The weakest interparticle forces of attraction as compared to solids and liquids, it is less, right? The force of attraction between the particle is less. Okay. Now, let me take a jar. So, just see, there are so many, 1, 2, 3, 4, 5, 6, 7, 8, 9 particles are there, okay? And they have this much of space here, okay? Cool. Now I'll reduce the space. I'll just reduce the space. They'll get adjusted. So here they had luxury, that they had so much of space to sleep, like this. But when I reduce the space, they are sitting. Now, oh, let me sit now. There's not much space. Now, I'll reduce the space even more. I'll just give the space just to stand. Just to stand. What you can see here, they are getting adjusted to the space that is available. If there is more space, they spread out. If there is less space, they compress themselves, right? So air occupies the space that is available. It's not like it requires only this much of space. Okay? So air occupies all the volume that is available. If it has so much of space, it will spread all over. It's like that. Okay? So let us see if we can compress air, right? Okay, I have syringe again. Yes, I have taken air. Okay, it's air, and let me close the tip. Now I'll compress. See, I can easily compress. Can you see? See, I'm till here. Yes, here. It's compressible. So gases are compressible then. So even you can try without the needle, right? Only syringe. Okay. So if you try to compress air, then you can compress. So particles of air come closer on compressing, and they are highly compressible, right? Air is highly compressible. Yes. So about that, let's discuss in the next session, Smriti, that when do they become liquid and like the change of states and all. Okay. Today, let us only talk about the 3 states of matter. Okay, cool. So air is highly compressible. Now, let's summarize whatever we have seen as the characteristics of gas or gases, right? One is indefinite shape, indefinite volume. They are highly compressible. What about the particle spaces? Do you think they will have fluidity? Can they flow? they do have fluidity, just like water. The more, tendency to flow they have, okay? Okay. So, very large interparticle spaces and the force of attraction is also less. Negligible interparticle force of attraction. Yes. Also, random motion of particles. So, if you see the particles, when pressure is exerted, they just exert pressure on the walls of the container. So if they are there inside a balloon, they force the walls of the balloon, they force that surface of the balloon to move further, to give me more space. Okay, so the random motion of particle that exerts the pressure on the walls of the container, right? Yes, so these are the characteristics of gases. Now think, see, I told you we can compress the gases. Now, we humans, we take advantage of all these things, right? So, what are the applications? What are the advantages that we can have on compressing the gases? Think. Have you seen LPG in the kitchen? The cylinders? What do you think it is? What is the full form of LPG? What is the full form of LPG? Yes, good. CNG, very good. But my question is, what is LPG? LPG full form. Yes, good, Monica. Very good. It's liquefied petroleum gas. That is actually compressed gas. Okay. It is a compressed gas which is in liquid form. Yes, this is one advantage of compressing the gases. So, LPG is nothing but compressed gas in the cylinder, which is in liquid form, which we can use it for, cooking and other purpose. Okay, so there's one more. Oxygen cylinders, which on compression again becomes liquid, and we use it in hospitals and other things, right? Yes, oxygen cylinders, and also CNGs, but these are not in liquid form. CNGs are in compressed but gaseous form. Okay, gaseous state. Okay, so these three are the main applications on compressibility of gases. Cool. So that's it. We have come to the end of the session. Let's look at the things that we have studied today. Yes, I learned that pressure doesn't affect liquid, but they have also gas particles between them. I don't get what you're asking. Yeah, okay, I did not understand the question. Cool, okay. So let's summarize what we have studied today. So we have studied there are three states of matter: solid, liquid and gases. And here we have the characteristics. If you want to take a screenshot of it, you can take it. Yes? Okay. So, solid, liquid, gases. Solids have definite shape. Liquid and gases, they do not have definite shape. Whereas when we come to volume, solids and liquids have definite volume, whereas gas do not have a definite volume. And when it comes to the compressibility, solids and liquids are not compressible, whereas gases are compressible. And when it comes to rigidity, solids are rigid, whereas liquid and gases are not rigid. Okay. Gases have the highest, okay, I can't, okay. Highest amount of kinetic energy, while solids have, it depends on the material. It depends on the material. Yes. Okay, cool. Okay then, so it's time for homework. Yes. So I need you to answer this question. What is the question? Give reason for the following observation. We can get the smell of perfume sitting several meters away. answer for this question. Yes? Okay, density is nothing but, okay, Sanju, see, imagine I have a container here which is not having any particles. Just imagine, okay, this this part is made up of, like, say, small particles like this. Okay, so these are all small particles. There's one more of the same size, okay, but the particles are like this. Which one do you think will have more density? Of course, this one will have the more density. A will have more density, right? That is because the particle number, the number of particles are more and they are very tightly packed. When it comes to B, the particles are less and the particles are like not very tightly packed. They are like freely just existing, right? So, density is nothing but how tightly packed the particles are. Got it? So, that's the reason 1 kg of iron and 1 kg of cotton, the size may differ, but the density or the weight wise, you think. Now tell me, if you have understood what density is, tell me how the particles will be arranged in 1 kg of iron and 1 kg of cotton. Okay, I want you to answer in the comment section 1 kg of iron and 1 kg of cotton. And I am not asking which one will weigh more and all. I am asking about the density and this amount, like how big it will look. Which one will be bigger? Okay? Yes. Cool. Okay, fine then. So, those who are already here many times, you guys know that we do so many sessions that help you in your exams, in your knowledge gaining. But if you're new, we do quizzes, we do have chapter notes, strategy sessions, concept sessions, everything for free. Where you can access this repository, just click on the link that is given in the description. And for more such videos, subscribe to the channel and hit the like button and share it with your friends. Until then, take care and bye-bye. I need to